All right. Thank you all for joining us. My name is Nina Gonzalez Silverstein, and I am a climate associate with the Washington University Climate Change Program. And I am really excited to be joined by these wonderful panelists for our first climate conversation of the spring 2021 semester. I will be asking each of our panelists a series of questions at the beginning, and then we will leave time at the end to answer any questions that you may have. So feel free to type the questions in the chat. Before the question period, a panelist may be able to respond directly in the chat, or I will also be able to hopefully bring it up during the question period. And so Julian is the other climate associate who helped me plan this event. So he's just gonna give a hello.
Yeah, I'm Julian McCall. I'm a sophomore here at WashU and a climate associate with the Climate Change Program. During the Q&A, you can either raise your hand to ask a question or type it in the chat. And additionally, all of our panelists have been spotlighted. If you put your Zoom into spotlight mode onto the speaker view, you'll be able to view them as the main picture on your screen. And finally, we ask that participants stay muted unless you raise your hand during the question period, and we'll call on you to ask your question.
Great, awesome. So now I am really excited to introduce these three incredible panelists. And again, thank you so much for joining us. And please introduce yourself when I call on you. So first we have Georgie Falster.
Hello, thank you so much for having me. I'm super excited about this. So my name is Georgie. I'm a postdoctoral research associate at WashU, although I am currently talking to you from Adelaide in South Australia. And so I study longer term climate change. So in comparison to our other two panelists, who you'll hear from in a moment, I look at weather and particularly climate variability on much longer timescales and also a range of spatial scales. So for example, I study climate changes on sort of interannual, so year to year, up to multi-millennial, so thousands of years timescales, and on very localized up to global spatial scales. And so my expertise, I guess, in this context is sort of understanding the change in the likelihood and severity of extreme weather events as the background climatic conditions change with global warming. So I'm looking forward to this.
Thank you so much. Yeah, we are also super excited to hear what you have to say and about your research. Our next panelist is Kenton Jawicki.
Hey everyone, yeah, Kenton here, and I'm the chief meteorologist at KUMU-TV in Columbia, Missouri. I am also very excited to be here, and I'm excited to hear from the other panelists too. Georgie, you just really I'm so excited to hear everything you know about, or what you're learning about all those large timescales of climate changes. But I, of course, focus a lot on the local impact. So I'm going to be able to speak on local extreme weather events, but also I have a series called Show Me Climate, where I discuss, of course, climate change in our warming world and how things are changing. And I talk with scientists and I talk and expose our viewers to other research that's actually going on. So it's not just me kind of rambling on, it's really sharing the scientific community to everyone, spotlighting them. So that's what I like to do. So yeah, I'm really excited to be here and to talk about all things weather and climate.
Thank you. Yeah, we're so excited to have you as well. And finally, Dr. Michael Mendez.
Good evening, everyone. It's still the afternoon here. I'm calling from, I'm zooming in from Los Angeles, California. I'm an assistant professor of environmental planning and public policy. And unlike my other two esteemed panelists, I'm a social scientist. And so I look at the human dimensions of climate change, specifically how climate change impacts such as drought, heat waves, extreme weather events, wildfires, how they're disproportionately affecting low-income people of color. And I also have a new book called Climate Change from the Streets, and it's published through Yale University Press, and it was released late last year. And it looks at how social movements, specifically how environmental justice movements are engaging in both the politics and the practice around climate change policy to focus more on public health and social justice and racial justice issues in their own backyard and in the streets. So thank you.
Yeah, thank you so much. So yeah, I am super excited to be joined by these three great panelists. And Georgie, we're going to start off with you. So I was hoping you could explain to the audience exactly how climate change is leading to this increase in extreme weather events. If you could kind of explain the science behind that so our audience has an understanding.
Yeah, I mean, and so this is a super interesting question, right? Because we all know that climate change is happening, but it's the extreme weather events that really drive home that it's happening to us and that it directly affects our lives today. Just before I jump into a bit of the science, I think that it's worth quickly clarifying the difference between weather and climate, which is simply that climate is sort of average or long-term weather. And so another way of saying that is that climate is what you expect, but weather is what you actually get. So for example, I think, Kenton will correct me if I'm wrong, but I think the long-term average March rainfall in St. Louis is like 70 millimeters or something. But depending on the particular weather in a certain year, this can be much higher or lower, right? Okay, so when we say climate change, we're talking about a change in long-term averages. In this case, the changes in global temperature that ultimately affect extreme weather events, including things like bushfires and floods and droughts and storms, things that affect people, as Professor Mendez just touched on. And so we've seen an increase in these extreme events since, I think, about the 1950s. And in many cases, this can be linked to human activities. And so we call this attribution, where scientists do a huge amount of work, often after sort of major weather-related disasters, to establish whether the event would have been likely or possible even without human-driven global warming. Okay, but then like the particular way that global warming affects extreme weather events depends very much on the type of event in question. So I'll just go through, I guess, to start us off, a few specific examples as a springboard to our later discussions. So I'll start with floods, which can be hugely damaging and are closely related to extreme precipitation events. So where a region gets far more rainfall in a short time than it usually would. And this can be from hurricanes or other sort of storms. And you might remember some major floods in the US in recent years. For example, there was Hurricane Harvey in 2017. I think there was some flooding along the Mississippi at the start of 2020. We're actually having some major and very damaging floods in Australia right now, particularly the past few days. So the first thing that we need to know from a science point of view then is that as the world gets warmer, it also gets wetter. And so what I mean by that is that as global temperature rises, the air can hold more water vapor. So there's more moisture in the air. And so during an extreme rainfall event, the amount of rain that actually falls is generally limited by the available moisture in the air. So what this means is that if there's more moisture available, then that rainfall event can be even more extreme, which is to say that there can be even more rainfall than there otherwise would have been without global warming. And then another reason we can get extremely high rainfall leading to floods is because of warmer ocean surface temperatures, which means there's more evaporation of water from the ocean that eventually makes its way to land. And there are several major known flooding events from recent years that almost certainly would not have occurred or have been possible if not for the long-term surface ocean warming leading to more moisture transport to land. And so yeah, both of these things, more moisture in the air and warming ocean temperatures, mean that extreme rainfall events that might have happened anyway, even without global warming, get even worse, to the point where there is so much rain that we get floods. And then also, of course, in the case of coastal floods, specifically, sea level rise also has a role to play, where higher sea level can take storm surges from something that would have been merely bad to catastrophically damaging. For example, in the case of Super Typhoon Haiyan in 2013, if anyone remembers that, it was a major disaster. And so a flip side, I guess, to floods is wildfire or bushfires, as we call them here in Australia. And I think we'll hear a bit about the social impacts of fire from Professor Mendes later. And so although, as I said, on average, so the whole world is getting wetter with global warming, there's a lot of geographic variability in that, which means that there are actually a lot of places in the world that are getting drier. And this is particularly the case in the middle latitudes. And so combined with rising temperature, the world's getting hotter, this increases the risk of bushfire in many areas. And these increases in wildfire can take the form of more intense fires or a longer fire season or a generally overall increased risk of bushfires happening at all. And these changes are via a few sort of pathways, which are the drivers of bushfire, for example, fuel load, which is how much vegetation there is that the fire can burn. Fuel dryness, which is how easily that fuel actually burns. Ignition sources, for example, lightning strikes are one of the biggest ways that a fire starts. And dangerous fire weather, things like strong winds, particularly dry, strong winds. And so for an example of how this has changed in California, for example, so potential fire fuel, things that a fire can burn in southwestern US has got significantly drier since the 70s. So the fuel burns more easily. And this has happened to a degree that would not have been possible without global warming. And so this global warming effect on wildfire is maybe a little bit more obvious or intuitive in that hotter temperatures themselves make bushfire more likely, as well as increasing their severity. And this is particularly the case in places that are already fire prone, that have warm, dry climates, where even hotter and even drier conditions mean drier fuel, often stronger winds. And in the case of the sort of fiery parts of Australia and then the southwestern US, California, for example, this sometimes also goes along with an increase in electrical storms, so which means more lightning to start fires. And something that's sort of slightly interesting or problematic about this is because global warming, the Earth is getting hotter, hotter weather means that fire seasons are getting longer. This means that, for example, the California fire season is starting to overlap with the Australian fire season, and these should happen at opposite ends of the year, right? And this is a problem because the US and Australia have historically shared firefighters and firefighting equipment. So this is something we'll have to deal with in the future. Oh, sorry, Nina. Yes.
No. That was a really helpful explanation, and also very that was really great.
Yeah, that's something that's become sort of particularly obvious in the past few years. I'm not sure if the last Australian fire season of 2019 and 20, I think that actually got quite a lot of press in the States, even because it was so bad and also so long, which is another problem.
Yeah, and so how are these weather patterns, how are they trending? What do we see 10 years, 30 years in the future in terms of these extreme weather events?
So in I mean, the other two panelists might have something to say here, but in the relatively near term, where we can't be extremely confident that there'll be much of a change yet in global warming. So, I mean, obviously this is all very heavily reliant on policy, right? Like, as long as we keep emitting carbon dioxide to the atmosphere as a global community, global temperatures will continue to rise, and hence we expect trends that we have seen in the next 10 or so years to continue. So we expect the world to get hotter, we expect dry places to get drier, we expect extreme precipitation events to get more extreme. Of course, a lot of these things, I mean, it's not all doom and gloom. A lot of these are reversible, if you like. They're not sort of, it's not that we've changed irreversibly our climate to be more fiery or more flood prone. If we could, you know, reduce and halt and slow down global warming, then these extreme, or some of these extreme events would also follow that.
Yeah, thank you. And I was wondering, Kendon, if you could speak a little bit to how you approach communicating about climate and about these specific weather events to the people who watch your TV.
Yeah, so a lot of the ways that I communicated is through my Show Me Climate series, which for those of you that don't know, Missouri is the Show Me state. So I did Show Me Climate, and I do stories. I'll kind of talk about the beginning of it. So how I came about doing this is after a couple years, it was really after about my first year of actually being on TV, which is forecasting every day, right? We make our own forecasts, we make our own graphics. We're not grabbing those from the Weather Channel or anything. We're using our own, knowledge to actually create that accurate forecast for everyone, for our local area. And the first thing I noticed was after a year, I noticed that our nights are more often warmer than our days will. So say that our high temperatures are 5 degrees above average, throughout a month. Our low temperatures will be 10 degrees above average. So our nights are warmer than our days in a big way. And so I noticed that after just day and day and day of forecasting, and I look at past data, climate data all the time because I'm a big data person. And that was the first thing I noticed. And then I started digging into more and more things, and reaching out to my colleagues in the climate community, and going to conferences and all this stuff. And I really got big into it and learning more, and realized I need to start talking about this. No one in my area, at least, is talking about this, and people need to know just the facts. They need to be exposed to the reality of what's happening. And so I decided to start a series called Show Me Climate, and I started it with the basics, because I was like, I really need to just make sure that I have all this information out there so people can at least start at the beginning if they need to. So the first thing I talked about was, what's the difference between weather and climate, which Georgie already covered, and all those things. What are some of those small things that we're seeing? I talked to our state climatologist, really just started getting the facts out there. And I would say the basic answer to that question, Nina, is just getting the facts. And that's the main thing I do. Is I'm not talking about a lot of hyperbole or anything like that. It's really, this is literally what's changed. And I think it's also really telling that when you just think about climate, you're not supposed to be able to notice the changes. Like generation to generation, we shouldn't be able to tell that the climate's really changing, like just from like our day-to-day lives. You really shouldn't be able to tell. But you can tell, if you just really look around, you can see, just take Australia, like Georgia was talking, right before the pandemic, early last year, they had devastating wildfires in New South Wales, especially. Now they have catastrophic, a 1 in 500 year event, potentially flood going on. And that's one thing that we're seeing. We're seeing more extremes more often, where you have this devastating drought and fire, and then you have a devastating flood. And then, you kind of keep going back and forth. You see different things. And we're definitely seeing that. I also don't just talk about local things, which if I did, some of the local things that we're seeing here in Missouri specifically, we're seeing, again, those warmer nights. We're seeing more heavy rainfall events where we are seeing more flooding. We've had quite a few flood events, just river flood events, over the past handful of years. Even a couple years ago, 2019, almost 2 years ago now, we had a tornado go through Jefferson City, And at the time of the tornado, which is the capital of Missouri, at the time of that tornado, we were also seeing near record flooding of the Missouri River, which goes right next to the Capitol. So some of the streets in Jefferson City were closed due to flooding, and we had a tornado going through at the same time. So those were, again, just two extreme things. That's a little different because the interesting thing about severe weather, and that's something you haven't heard about today, and that's something you don't hear probably too much about, even if you're doing some research, in climate and weather events, severe weather specifically, when I'm talking about severe thunderstorms and tornadoes, that making that connection to how those are changing because of our warming world is much more difficult. When we talk about floods and we talk about droughts and wildfires, and when we talk about hurricanes especially, those are all pretty easily linked to getting worse because of anthropogenic climate change. With anthropogenic is just human caused, human created climate change, our warmer world. But with severe weather, it's a little different. And part of that, I'm actually on April 5th, a little tease for any viewers that are on here. It's our severe weather special, and I talked to just recently one of our tornado experts in America, and I asked him about this. He's also a big climate guy, and he works for the government. And one thing we talked about is how we're seeing our jet stream pattern change a little bit. It's weakening a bit, and that changes some things too. Basically, a lot of these ingredients that we need for severe weather aren't happening quite as often. And so one thing that the jet stream can do if it's weaker, maybe if it's weaker, then it can allow some of that polar vortex to come down, which is why we're still going to have winters in a warmer world. We still get winter, and we're still going to get extreme winter events. In fact, those are likely going to happen more often. Again, talking about extremes, they happen more often. It's like we just saw happen this past winter, a month ago, almost a little over a month ago. The terrible impacts that had on folks to the south from that polar vortex breaking off and coming down. And it was allowed to come down because our jet stream was a little weaker. Our jet stream is weaker because we're seeing a warmer world. And so also when it comes to severe weather, like thunderstorms and tornadoes, we're seeing those change because some of those ingredients aren't coming together as often. And so the pattern that we're seeing with tornadoes specifically is that we don't have as many tornado days. That's actually either stagnant or actually going down a bit, where we're just not having as many days with tornadoes. But what's interesting is what's going up is the days that we have tornado outbreaks, the days that we have more tornadoes. So basically, kind of again, talking about that variability, talking about the extremes, we're seeing more days when we do see those ingredients come together. It's an extreme event. It's a big outbreak. We already saw about 49 tornadoes go through the South last week. Now, tomorrow, the South again is under the gun, almost the same area. Could see another tornado outbreak again just tomorrow. And so we're seeing these big events happening, even though the actual days with just a tornado are going down. So we're seeing some really interesting things just with severe weather, but it's hard to make those connections exactly, which I think is fascinating. And that's why I'm bringing that up too, and telling everyone about it there on April 5th, because climate is a growing science. That's why we have so many scientists and so many researchers, doing all this stuff to figure out what's going on. And I like that we kind of don't know everything yet, and that there's still more to learn, and that we can figure it all out together. But we really also need to, of course, figure out then, you got to, look to the policy then, of course, too, to say, well, we know why we're changing so rapidly, right? This is why we know it's because of the carbon dioxide and the methane that we're emitting. And then we have to come together and figure out how to stop that, because we know that this is just going to keep getting worse. One thing that my friend there, the tornado expert I was talking with, mentioned to me is that he expects non-tornadic wind events like derechos. We saw him move through Iowa, right? You saw those fields maybe with the corn just completely on its side and all that kind of stuff. Wind events, which can be just as damaging, if not even more so than tornadoes, he certainly does expect those to actually increase. He's like, we can't make a lot of connections to some of these things, but I expect those to increase. So we are seeing some trends there. So a lot of what I do is I just talk about the facts. I talk about what we're seeing, talk about what's changing and what's likely going to continue to change, continue to get worse, because it's important that people know the real science of what's going on. So I'll talk locally, I'll talk nationally, and I'll talk internationally as well. We'll talk about all of that.
Yeah, thanks so much. And how's the response been to your Show Me Climate? And have you experienced any pushback? Yeah.
So I've been really lucky that my station has allowed me to talk about it. Like even from the first time that I brought up that I wanted to start the Show Me Climate series, they were all for it. So they've been really supportive, which is great because not every station will. Luckily, my station is actually owned by the University of Missouri. We're the only network affiliate. We're an NBC affiliate and a CW affiliate. We're the only affiliated advertising station in America owned by a university. And so we're locally owned and all that kind of stuff. And we're not owned by a big company. And so we're kind of we are allowed to make up our own mind on what we show and how we give the news and the weather. And so I'm lucky that I'm able to do that. And so from the audience, I haven't gotten much pushback, which has really been positive. I'll tell you, when I first started the series, I told you I started with explaining the difference between weather and climate and kind of the smaller things. I did a whole week of that, like 5 days in a row, to get started. And I was so nervous that I was going to get like all this hate because you know, those are the loudest folks, right? The people who are scared of that reality and don't want to accept it are usually the loudest. And so I was nervous, but I honestly didn't. I overwhelmingly got love for talking about it. And I got support from viewers saying, I want to know more. Please keep telling me what's happening. I didn't know this. Thank you for sharing it. So that really helps me to keep going. And it's really nice to know that folks are interested and they do want to know this information. And they should know this information. When I go and talk to third graders, I go to a lot of third grade classes. That's where they teach weather a lot here in our area. And I'll go and I talk to them about a bit about climate too. Really, a lot of what I do is just explaining the difference between weather and climate. But I explained to them that this is going to be something you're going to hear about more than any other generation before you. Climate change is going to affect the younger generations more than anyone before them. So I explained to them that that's something that they really need to know about. And in my elementary school, even I wasn't learning about climate. I didn't know what that was. But it's not that way. Things have changed so rapidly that now it's a big deal. So yeah, I just again, just talk about the facts and luckily folks have been really supportive.
Yeah, that's great to hear. Thank you for that. And now I was hoping to ask Dr. Mendez, you do a lot of really interesting research. And so I was wondering if you could speak more broadly to the impacts of these extreme weather events like hurricanes and wildfires to different communities. And then if you'd like to speak to your own research specifically, that'd be great as well.
Sure, thank you for the opportunity. And I think Georgie and Kenton did a great job in really highlighting sort of the great challenges we face as a society. One of the existential threats to our planet is climate change, and it represents one of the greatest challenges, but it also represents one of the greatest opportunities to reimagine and rethink of how we're going to plan our cities and societies, because we know the primary source of climate change is the combustion of fossil fuel burning. And that combustion of fossil fuel burning is contributing to greenhouse gas emissions, carbon emissions, but also local pollution that stays at the neighborhood scale that affects people's health. So really taking a look of how can we change our practices and do fundamental changes in the way we live and the way we think about our different lifestyles and worldviews. This research is particularly important to me because I'm from California, and just like Australia, we're one of the hot spots for climate change impacts and multiple types of impacts, multiple types of compounding of disasters that are occurring. So in California, we are experiencing, of course, a major climate change crisis. In the last year alone, millions of people have been impacted by multiple disasters such as wildfires, blackouts, heat waves, drought, the hazardous air quality that comes with that, and of course, currently the ever-present COVID-19 pandemic. So these compounding of disasters have cascading health, social, and economic impacts. And due to existing structural inequality, these impacts are disproportionately affecting low-income people of color. So now more than ever, it is crucial to understand how these events amplify existing inequalities and how to lessen the resulting harms. Because we know that climate change is real. As my panelists mentioned, show me climate change, and most people can attribute some type of change in our weather and our climate to anthropogenic climate change. But the reality also is the way that people are experiencing climate change impacts, whether it's wildfire, extreme weather events, it's not even. That some people that are more socially vulnerable, low-income people of color, the elderly, the disabled, are bearing the brunt of those impacts. And our climate policies, not just our mitigation policy, but the climate adaptation, that is, that we understand that these impacts are happening now, and how do we safeguard our communities, our society, our infrastructure from these impacts that are happening more frequently and more severe over time. And oftentimes, the most vulnerable in society, the homeless, undocumented migrants, are not provided with that. My research, in addition to my book, Climate Change from the Street, which I just mentioned was published earlier last year, I also look at wildfires in California, extreme wildfire events, and how it has impacted undocumented migrants and specifically farm workers that are coming from Mexico that are Latino, but are also indigenous and speak neither Spanish nor English, and how our disaster systems are essentially rendering this community invisible in the context of public policy and disaster relief. So, and on the paper that I have co-written with community groups working directly with migrant rights groups, that we understand that given their social status, groups like undocumented Latino and indigenous migrants are particularly vulnerable to disasters such as wildfires and require special consideration and disaster planning. This is because they are disproportionately affected by racial discrimination, exploitation, economic hardships, less English and Spanish proficiency, and fear of deportation in their everyday lives. So in essence, this is their pre-disaster marginalized status. And as we all know that if you have some type of disparity in life, in your society, it's likely that that's only going to be exacerbated in a disaster. So our research looks at how can we look at the human dimensions of climate change and mitigate them, and how can we adapt in a more equitable and just manner.
Yeah, thank you so much for sharing that. I'm wondering what are there specific ways that I actually, could you speak more to how being undocumented and how documentation status is particularly relevant?
First and foremost, like as I mentioned before, undocumented migrants are often rendered invisible in the context of public policy because of systemic racism and cultural norms of who is considered a worthy disaster victim. Just like the homeless population, oftentimes these people are seen as disposable, less than human, and many governments, both state, federal, and local, have a very limited amount of resources, so they prioritize some lives over others. So in this disaster planning process, political choices are overtly and explicitly being made to prioritize some lives over others. And one of the most basic ways that it happens is three times of mutual aid assistance. The first would be at the federal level, disaster relief funding from FEMA, the Federal Emergency Management Agency. Undocumented migrants are ineligible for that funding, as well as unemployment. So should their jobs be burned down by a fire or some other extreme event, they're not allowed to access unemployment assistance, as well as healthcare. If they get hurt while during a disaster or while laboring in mandatory evacuation zones. So in places like California, in particular Sonoma County, which is my second research project I'm doing now. The first was in Santa Barbara and Ventura County. Sonoma County has issued what's called access verification permits. So these are permits that employers, vineyard owners, and other farm owners request to the Agriculture Commissioner and to the county government to allow farm workers to enter into mandatory evacuation zones that are considered hazardous for the general population, but to be able to allow them to enter into those areas. And these individuals are often pressured to do this work because any day lost of work could be detrimental to their family, as well as it can hurt them in the contracting labor process if they didn't show up for work, and then the contractors remember that and you're sort of blacklisted. So these migrants enter into these mandatory evacuation zones, and if they get sick, hurt during this, again, they can apply for unemployment insurance, disaster FEMA funds, or healthcare. So those are some of sort of the gaps that exist for this community during disasters and wildfires, which some could argue are climate-induced disasters.
Yeah, really puts them in an impossible state. So Georgie, I did see your comment in the chat about the aerosols, and I was wondering if you wanted to speak a little more to that.
It was just something that I was reminded on. So this pertains particularly to tropical cyclones, really, which, you know, is a sort of a precursor to hurricanes. And it's a good point that Michael made. You know, anthropogenic or human-driven climate change, of course, is not only emission of carbon dioxide to the atmosphere, but also the emission of, call them aerosols, tiny little particles, for example, you know, of soot and whatnot. And these, they both decrease air quality, which is immediately hazardous, but this also has a climatic impact. For example, having more of these little particles in the place where a tropical cyclone is developing, for example, maybe in the North Atlantic, this can change the way that a tropical cyclone develops. And I think this is sort of an active area of research, but then it also speaks to you know, how climate change is also probably changing the predictability in some ways of things like tropical cyclones. Well, I've got the floor. Oh, sorry, go ahead. I was going to ask a question to Dr. Mendez, but.
Oh, you can go ahead. I was going to talk more about hurricanes, but you go ahead.
Oh. It's a hand wavy one, but, you know, I just simply, I mean, I guess I haven't thought so much on this aspect, the disproportionate impact of extreme events on vulnerable communities. And I mean, given climate change isn't going away in the short term, I mean, hopefully it's, you know, we can do something about this in the longer term, but on the next 10 years, say we expect fires and floods, are there like specific things that you know of that governments could do to extend protection to vulnerable communities, like new infrastructure funding programs? I mean, it's a sad state.
Yeah. There's a lot to be done in terms of mitigation and adaptation. So just for the students out there, the difference between mitigation and adaptation. Mitigation is the reduction of the causes of climate change, principally greenhouse gas emissions. So how do we mitigate those emissions, stop them from occurring at present and in the future? And adaptation is acknowledging that, okay, there's already been a lot of greenhouse gas emissions that is affecting our climate and all these weather events. So the impacts of climate change are happening now and in the foreseeable future. So how can we protect our societies from these foreseeable impacts now? So I'd like to add also, when you talked a little bit about aerosols, so it's not, of course, it's not just wildfires, but also look at how heat waves is making air pollution worse. So we know the precursors of smog, NOx and SOx comes from fossil fuel combustion. Smog is formed through interaction with light and other sort of processes, right? So when it gets hotter and we have the hotter weather, extreme heat waves, that increases the process of smog formation. So we have more smog. And in places like California, we had been a leader. We have always had smog, and we're known for that, but we had been a leader in reducing our smogs in the 80s and the 90s. But then in the 2000s, and especially in the teens, we're hitting back, not because we're not mitigating enough, but it's because of climate change and because of these processes that are speeding up the process of air pollution. So the biggest issue to safeguard our communities and the most vulnerable is, of course, reducing these emissions that are causing both global and local crises. And then on adaptation side, that it's really acknowledging and mapping out and identifying those most vulnerable communities instead of ignoring them and acting like they don't exist, and then really trying to build that airplane in the air as these disasters happen. Places like California and Australia, we've always had disasters, not to this extent, but we've always had disasters. In the last 10 years. They have been increasing in severity and frequency, and to some extent, we can say they're foreseeable. And if we have the capacity to really plan ahead and safeguard some of those communities.
One thing we're also seeing with, you guys were talking about aerosols and particles in the atmosphere. Because of the heat that we're seeing too, and we're getting longer growing seasons, right? We're seeing it getting warmer earlier. That's something we're seeing here in Missouri and most places, warmer earlier and warmer later. So summer's kind of expanding, winter's shrinking, and the other two seasons are kind of in the middle. But that means that our growing season is longer, and that means that we also have more pollen in the atmosphere. So one of the big things that we're seeing, even here, certainly in Missouri, actually another story I'm working on for in the next couple of weeks, but we're working on, we have worse allergy seasons. And an allergy season can almost be all year long now too, because there's worse pollen than over to our west. And sometimes if there's enough pollen, even in winter, that pollen can get in the jet stream and it can come our way too. So even though there's more pollen just in other parts of the world, that can sometimes even get into our air, even during winter months. So we're seeing more pollen because of that longer growing season. Farmers are kind of interesting because they're impacted a little bit by a bit of a longer growing season, but also they're dealing with more extremes. So they're getting, again, more, when it's dry, they're in a drought. When it's, they're getting the flooding happening more often too. So they're really having to deal with a lot of this variability, never know what the next season's quite going to bring them, which brings a lot of stress. Also though, they can be a big part of the mitigation effects of climate change, because what we're seeing is farmers, if they change some of their methods, if they go into more of a no-till, where they're not killing that topsoil can actually, if it's a really healthy soil, it can be a really great way for carbon to exit the atmosphere, and it can go into that soil, and then nitrogen can too, and it can actually be a natural, they can have kind of natural fertilization. One of the biggest emitters also of greenhouse gases is actually the creation of artificial fertilizer. So also by then, again, changing the way that you're farming in those techniques, you can kind of help suck a lot of carbon dioxide from the atmosphere. You can also prevent a lot of it from being released into the atmosphere by the creation of fertilizer. So a lot of interesting things too, just talking about plants in general, because of course plants love carbon dioxide and they thrive on that, but that can also have some other negative effects too. Also, we're seeing a difference in poison ivy, which we have poison ivy here in Missouri. We're seeing over time, we've already seen this change, and it's expected to continue with our modeling, where poison ivy is getting bigger, taller, but it's also getting more potent, where actually like the actual poison of that plant is actually getting more potent, and it could be more extreme. So we're seeing that change because of our warming world. And we're also seeing ticks actually get a bit more widespread. They're actually spreading a little bit further to the north as well. So some areas that aren't quite used to as many ticks are getting more ticks, which can of course spread disease also. So there's a really big health impact for more people going to the emergency room from asthma, for asthma-related illnesses from the pollen. Again, more diseases from ticks and other things like that. So there's a huge health aspect to all this, which Michael, you might even be able to speak a little bit more on that too, just how, the health aspect, we're seeing more costs of, medical bills from, pollution or from asthma or from all these other things as well. And that can be more expensive.
Yeah, no, definitely. I think asthma, people living next to these fossil fuel point sources definitely are suffering from asthma and other respiratory diseases. And there was great research done by Harvard late last March of last year on showing the connections between respiratory diseases and essentially environmental justice and COVID hospitalizations, and that people that had asthma from these environmental justice hotspots living next to essentially a polluting source more likely to be vulnerable to complications from COVID-19 pandemic.
Can I ask Georgie a question? I'm
Sure.
curious. So one of the big questions that I'm sure most of us get if you ever start talking about climate is people say the climate's always changed, right? So why can you because you were talking about how you study those long-term climate trends and things like that. Can you speak to that a little bit about why this is different than normal?
Yeah, I mean, I guess one of the biggest differences is the rate at which the climate is changing. So this is completely true. The climate has gone up and down throughout the last thousands, or particularly hundreds of thousands, millions of years. It's been much colder and also a bit hotter. I mean, not that much hotter now than it has been, in the past. But these are changes that have typically, a rapid change in the past from a glacial, so very cold, to an interglacial, so very warm. The change between those two states typically takes at least, let's say if it happens really quickly, I don't know, a few thousand years. It takes a lot longer. But these are the sort of changes that we're now seeing in like a decade, or in sort of 30 years, we have a degree of temperature rise. That's absolutely astonishing. It's so fast. And so whilst a lot of climate systems in across the world could easily adapt to a 1 degree temperature range if it happened over 1,000 or 2,000 years, they simply can't keep up. So the climate is changing quicker than our ecosystems and our environment can change. Animals can't follow the changing climate. Plants certainly can't. And of course, humans, we engineer landscapes to a degree to suit ourselves, but we absolutely can't keep up with the rate at which the climate is changing. Not only that, at this point, it's mathematically possible to prove how much we've changed Earth's climate. But I think that's one of the easiest, or the best ways to think about it is the speed at which the climate is changing now. Earth just can't keep up. It's a thorny question.
Yeah, thank you so much. So yeah, we are entering our question phase. So if anyone has a question, feel free to type it in the chat or raise your hand. My mom asked a question, and so she asked, what does the panel think the most important and viable policy initiatives are that would begin to address the challenges raised here?
I would start one of the biggest emitters as sector, looking at sectorial based type of mitigation issues is transportation, at least in California. I don't know in Australia and other parts, but in California and the United States, the biggest emitter of greenhouse gas emissions in the course of local pollution is the transportation sector. And I think far and beyond, we are behind in electrifying our transportation sector, from our public transportation systems to heavy and medium and light freight, our trucking industries as well. And electrification of buildings and homes, of course, and renewable energies, of course, but it's looking towards path of how can we have more sustainable transportation and homes systems. And the biggest thing is a movement towards electrified infrastructure in all segments of our society, particularly the transportation. And again, that has a strong environmental justice element, because most of this transportation infrastructure, from logistics to ports, are in low-income communities of color throughout the United States.
this particular panelist thinks. I mean, so in a lot of cases, the technology for renewable energy, so as opposed to getting our energy from coal or gas, technology is there, right? So for example, hydrogen-based energy, that's a rapidly emerging technology. And then of course, wind and solar. And I think are very viable because the costs of these energy sources are also decreasing rapidly. And I think that government support for these to make them even more, sort of phasing away support from fossil fuels and toward renewables, which are really at the state where we could be almost reliant upon them in many cases. I think that is a worthy direction, and particularly in countries like the US and Australia, where where we are set up to do that. Countries that can shift away from fossil fuels, I think, should.
Yeah, I can. Someone's calling me real quick. Sorry, let me stop that. One thing that I would really just add to this is that, I think folks just really need to wrap their heads around, and especially the people that are making a lot of money off of fossil fuels, is the only way we're going to stop this is by stopping fossil fuels. And that means leaving oil in the ground, right? That means it's there and we're not touching it, which is, of course, not at all how we've lived. So it's making that change, but also realizing that once we get into renewables, right, that's going to be, it's renewable energy, right? So it's renewing. There's not a finite amount of it. So that means it's going to be what we're using, likely, at least from what we can see, at least forever, or at least for, until we figure out what the next thing is. And so that's going to be a huge investment. So it's interesting when people say, that we could lose a lot of money by switching, but really, if you invest in this now and you start building that, you're going to be set for a very long time. So I think, the economy can be extremely strong, and it's just about everyone coming together to finally agree on something and to move us forward in that right direction.
Yeah, and I wanted to just note briefly, Dr. Mendez, if you want to add something after. Our next climate conversation is actually we're going to be talking about nuclear energy and kind of the pros and cons. So just a little shout out so everyone is aware. But Dr. Mendez, if you would like to add something to that, go ahead.
Oh, no, fine. But I did want to ask Georgie a question, if I can. The emergence of atmospheric rivers has, happening all over the globe, but in California especially. Can you talk a little bit about that and what they are and why they're so significant now?
Atmospheric rivers, eh? Look, I won't pretend that this is a field of expertise for me. They've actually only just emerged into the field of consciousness in Australia. At the most basic level, what an atmospheric river is a really concentrated plume, essentially, of water vapor. So where we have so when we get rain, that means that has condensed in a cloud from vapor. And, if we have more vapor, that it can condense to form heavier rain. And what an atmospheric river is, for example, there's a well-known one in California, the Pineapple Express. There we go. It's a really intense plume of this water vapor, which means it has the potential to bring extremely heavy rainfall. I'm not entirely sure. They tend to come off better, sort of larger bands of moisture, and they particularly we notice them when they come over the continents. So timely, the Australian floods right now are actually caused, at least part, by an atmospheric river. I'm sorry, that's not a very good answer, but essentially it's more or less what it sounds like, but it's just sort of a river of vapor that then condenses to very heavy rain.
Great. So we thank you all for the questions. These are all really great. Laura asked a question that I was hoping to get to about infrastructure. And we saw in Texas how much poor infrastructure can be really devastating. And so I was wondering, I'm sure Dr. Mendez, if you want to talk about some of the impacts of, I don't know if you could speak specifically to California, or about just infrastructure as how these extreme weather events can impact infrastructure that might not be super stable as of now.
Sure. I guess, Texas is another example of how there's unevenness in terms of how we're experiencing impacts, just like Hurricane Katrina in New Orleans, in Texas, and that's, I guess, the southern eastern part of Texas, and places like California. When we do have disasters, first and foremost, they're most experienced most heavily in low-income people, the people that have the least resources to prepare and recover from these disasters. And we have a crumbling infrastructure throughout the United States, and more so in these poor neighborhoods that have lower tax base, lower political power to get essentially capital projects from Washington, D.C., from the state capital, or from the county and city governments. So we have there's a strong refrain, or sort of an idiom and the social sciences, that there are no natural disasters, that disasters essentially become disasters when they reach society. So, and that it becomes a disaster because we didn't plan ahead, and we specifically let these impacts happen when we knew and we had forethought that this could actually happen in these communities, but we chose intentionally not to do that. And we see that in Hurricane Katrina, and we see that in Texas, of what communities actually were left without running water, without electricity and heat, and other communities that were nominally impacted. And with climate change, you will see that more and more that no longer can you run away with affluence, and that you can't go off to your vacation home. You can't go out to Cancun like a senator did in Texas, but eventually that there's a feedback loop and boomerang pattern, and that these sacrifice zones where all that environmental pollution, contamination, and impacts are happening, essentially is going to affect the larger ecosystem. So if you look at a systems approach, that these sacrifice zones of pollution and impacts eventually will have a feedback in our entire system, and that's happening more and more.
Yeah, thanks so much. Kenton, did you want to speak to, I know there's a question directed to you.
Yeah. It was asking about the reception from other meteorologists about talking about climate change. And again, communicating this to everyone is so interesting because, of course, there are politics involved, which is terrible because we're talking about factual science. We're not talking, of course, when you want to talk about how to, change into renewable energy and the best policy to go into that, that is getting into politics a bit, right? We know we need to, all the science tells us we have to stop emitting massive amounts of greenhouse gases. How we do that, that's politics, but just the science of actual climate change is not political. It's not an opinion. Climate change is not an opinion, it's a fact. And so unfortunately, politics are involved, and some people don't want to talk about it. Some people won't talk about it. I had a news anchor who I used to work with actually reach out to me when I started my Show Me Climate series, and they said, wow, I'm so glad that you're doing this for your viewers, because our meteorologists won't let us talk about it, and certainly won't let us do a national climate story right before weather, because they don't want to be like connected to it at all. And that's just how, again, it just depends on where you work, depends on who your meteorologist is. But it's also very polarizing for us too, because we do see a lot of backlash just in general from, weather, getting the weather wrong, or which doesn't happen as often as people like to think. Breaking into The Bachelorette during a tornado warning, and getting literal hate mail from that. So there's just, it's a pretty polarizing issue. So it's definitely different and depends on who you are, but and also who your station is. As I mentioned earlier, some stations won't let you talk about it. So there are politics involved. Unfortunately, I'm lucky that I don't have to deal with those, and I can just talk about the facts. Georgie, I do want to ask you one of these questions though, because it's so interesting about that attribution. Someone brought this up, and when I started talking about climate change and really learning about it a lot, only about 6 years ago, the thinking was like, okay, well, just because it's an extreme event, we can't attribute that every single extreme event to climate change, right? You can't do that. But I'm seeing now that that's kind of changing. Am I right in that?
Yes and no, and again, it depends very much on the type of event in question. But it is a super interesting field, right? I just typed out a very long response to Christopher, but thanks for the great question. So the difficulty in this attribution science is that the climate is naturally very variable, right? And particularly some things like extreme precipitation events. If this is naturally very variable, then it is harder to detect the effect of global warming on an extreme. As Kenton says though, as events, these extreme events are getting more common and more severe. It is increasingly easy, or possible, to attribute these to global warming. And you can see that if any of you read the IPCC assessment reports, you can see as they've gone by, the degree of confidence in attributing extreme events to global warming has generally increased. But essentially, we sort of do two things. We look at records of past weather and climate in that area and see, how many events like this have occurred in the past, and we can do some statistics and figure out how likely that event is to have happened. But then the other thing that we can do is to use climate model simulations. So these are numerical, very, very, very complicated numerical simulations of the global climate system that we can run in computers. And the cool thing about these is that we can run simulations of weather and climate variability, how it would have looked without global warming. So we can sort of take global warming out of the equation and then see how likely it is that that event would have happened. So a good example is that, without global warming, say that we've seen this long-term increase in sea surface temperature. So we've got a higher sea surface temperature background state, and without that sort of higher background state, there are sort of many events we can say wouldn't have been possible, extreme precipitation events. So that's probably the two ways we look at observational data. So in the example of the, just one example from Australia, the bushfires just gone. Bushfires are quite difficult to model because there's so much variability that goes into resulting in a bushfire. But according to the historical record, we can say that the frequency and severity of bushfires in Australia has emerged outside of the range of natural variability now. It's worse than it would have been or has been in the past, and we can reasonably confidently say that this is because the combined effects of global warming. So it's an interesting field, and climate model simulations play a large role. Sorry, did I answer that question all right? I hope I did.
Yeah, thank you so much. Okay, it's going through. Oh, so actually, this is an interesting question. Is there any information specifically to Dr. Mendez? Is there any information about the mental health effects that these weather events are having?
Sure. I think the American Psychological Association has published various opinion pieces and highlighted recent studies showing that sort of climate anxiety and climate trauma is real and does exist and is being experienced more widely now because of the severity and frequency of these events and impacts. And for my research that I'm actually doing again on wildfire in Sonoma County, so this is a place where there's not just wildfire, but it's extreme wildfire. So this is wildfire behavior that's unpredictable, that sort of has its own, mind of its own, and heavy gusts of wind and firestorms, and last for much longer periods of time. And are more destructive and more deadly than your average wildfire, unfortunately. And so a place like Sonoma County in Northern California, which many of you may know from the great wine that comes there, that place has had in the last 5 years multiple extreme wildfires that are ranked in the top 5 and top 20 of the most destructive and deadly. And this has happened multiple times in the last 5 years. So that, as I started this the second research project there, I've started to see how trauma and is coming up as an issue where there is not only disaster fatigue about even thinking about the next wildfire and not even wanting to deal with that, but remembering it. So, I'm interviewing people, and my co-authors are also, advocates in that area, and, they're writing with me, and, and we have to take a step back and acknowledge sort of the trauma that they have experienced after these multiple years of extreme wild events that have happened to their family, their friends, and just the landscape. It's seen that, what kind of effect day after day, year after year, you see that sort of landscape, and then the impacts that people are having both in health as well as economic and social. So it is quite real. And I've read the studies, and they exist out there, but this was the first time that I saw it firsthand or experienced it firsthand, at least in terms of the work that I'm doing now.
I think you talking about the trauma is really interesting too. Another place we're seeing that a lot, the mental trauma from this, is in hurricanes. People along the coast. Just this last year, of course, if you guys don't know, 2020 was like historic hurricane season for many, many, many reasons. But like the entire coastline from Texas all the way up to Maine, through Maine, was under some sort of a hurricane or a tropical storm alert, except for one county in Florida. The entire thing was throughout the season. Before 2005, we had only had 20 hurricanes in one season. Then in 2005, we got up to, I believe, I have the number right here, we got up to 28. And then, so in 2005, we had 8 more than we had ever had before. And then last year, we got up to 30. And we had the most landfalling named storms in America last year by, I think, 2. I think the record was 9, and from like 1911, and then we had 11, I think. We had the most rapidly intensifying hurricanes, all this stuff. So there was one area in Louisiana that got hit by a hurricane just within a couple weeks of each other in the same area. So they hadn't even recovered, obviously not at all, from the last one, and then they got hit again. And so there's actually some migration potentially going on. Climate migration is something I don't think we've talked about much, but we're seeing that where these areas that are getting inundated by these climate disasters, they're literally moving away. They're going somewhere else, where at least that type of a climate disaster isn't gonna hit them anymore. And maybe they might have a different one, but yeah, we're seeing some migration because of that. And that's, there's a lot of trauma that's involved from these extreme events happening more often.
That's a really good point. Actually, I totally forgot to talk about that too, but that is a particularly well-established part of global climate change. For example, is that the storm tracks in both hemispheres will generally be moving poleward. So these extreme events will be focused in places that are different to where they've historically been, that might have more of the infrastructure or policy to deal with them. That's a really good point, Kenton.
Yeah, thank you so much. So yeah, we are reaching, we're going to wrap up in a few minutes, but I did want to try and end with a little bit of optimism. Just, we all need it, especially during this COVID and everything. So if you have any thoughts that you want to add any things that we as just people should know, or we should be doing to deal with this very, very real and scary threat, I'd love to hear your final thoughts.
I mean, it's a sort of apathy and misery helps nobody, right? And the fact is, in most components of global climate change, if governments, particularly governments, but people act now and quickly, well within what is possible for us to do, it is possible to slow and eventually sort of halt greenhouse gas emissions. It's absolutely possible. And a lot of these events, like droughts, fires, floods, extreme rainfall events, they have a very fast response time. So if we slow the rate of global warming, we'll slow these changes. So, I mean, that is an important thing, I think, for all of us who work in this space to keep in mind, that it's not like, you know, it's not all doom and gloom. It's well and truly possible if, you know, we all band together to to do something about this still. We're not, you know, we're not at any point of no return just yet. It's about as positive as I can be.
Yeah, I like that. And there certainly is a lot of optimism to be had. And I hope that we still have that. One thing I would say is, if you're wondering what's the best thing I can do, right? I would say talking about it is the best thing you can do. And it's one of the hardest things you can do too, especially talking about it to maybe people that you know don't necessarily, maybe even they don't even believe in climate change, but just having conversations, hearing them out, educating, all of that stuff is the best thing to do. And also try not to take the whole world on your shoulders. Okay, try not to. A lot of us, in the environmental world, are, just feel so like we need to change it and we want to do it all ourselves, and you can't. All you can do is what you can do, and then just really try not to let it boggle you down too much, and try and keep that optimism, because there is reasons to be hopeful, and we see that quite a bit when we see, I see farmers that are, changing the way that they're growing their crops more, and we do see policy changing. We see car companies making more, electric vehicles, or have plans to, and there are things that are changing, and we just have to keep pushing forward and keep going for that, but try not to let it boggle you down too much.
And I'd like to add that, again, yes, climate change is one of the greatest challenges facing our society and our planet, but it's also, as I mentioned earlier, the greatest opportunity for us to really reimagine how we live, work, play, and have fun. And because our lifestyles are contributing to the warming of the planet and greenhouse gas emissions and other pollution, but it is a great opportunity to think first and try to imagine something new and different. And then the biggest advice I would have is that social movements and politics matter, and being involved and putting political pressure and organizing. And one person, two people, 3, 5 people, that's something that scales up and eventually gets heard by people in the policymaking world. So being able to be organized, protest, and make some noise about this issue, and show that constituencies and voting constituencies in particular care about this issue, and are going to be asking politicians as they on the campaign trail doing their campaign stumps, what are their positions on climate change, sustainability issues, environmental justice, racial justice, and how fast are they willing to move on these issues.
Well, great. Thank you so much to all of these 3 amazing panelists. I think this was a really great discussion, and I'm really appreciative of the fact that you guys really communicated with each other and made my job very easy. So thank you for that. And I just did also want to note, just in terms of the climate change program, we do have another climate conversation coming up in about a month that'll be on nuclear energy, and we'll be joined by Dr. Louie and hopefully a few more professors here at WashU. And then I also wanted to highlight the Missouri Climate Dialogue, which will be happening on April 7th. And we are extremely lucky because Congresswoman Cori Bush will be joining as the keynote. So that should be a really exciting event. And yeah, check out Dr. Mendez's book. He put it in the chat right there. And we can also share resources on our website as well. You can find the recording of this event on our website, climatechange.wustl.edu. And I think that's it. Again, thank you so much to all of the all these 3 panelists. It was a really great conversation, and thank you to everyone who asked questions. So have a good night, everyone.
Thank you.
Bye, guys.
Thank you.
Thanks for organizing this.
Thank you very much.